Vertical and adjacent angles, two angles that are important in geometry. Let's learn all about them, shall we? For this, I'm going to do a little quick mini lesson. And for this, we're going to just draw a great X, like for X-Men or X people. All right. Any angle I can denote like this, where I have a certain color and a certain mark. If I give the same mark somewhere else, then that is a code that these angles are the exact same. They're congruent, they match, they're equal. Same thing if I give a different mark and even a different color. Notice there are two of these, and they're in blue. The blue ones match, and the red ones match. Well, you could also notice that, let's highlight this. You see that wide V shape? It's like right above it, if I was to draw it. There's a V there and a V there. It turns out that angles across each other in V's are congruent, and the V is important because the V stands for vertical. So anytime you have this X formation, or really just any two lines that cross each other, the ones across from each other in either direction, where they're on separate sides of V's, are vertical, and they're congruent. All right, what about adjacent? Well, adjacent simply means next to. So angle 1 is directly adjacent to or directly next to angle 2 and angle 3. But even though it's vertical with angle 4, it's not adjacent to it because you'd have to travel across the V's, across this little vertical spot here, and that therefore is not adjacent. So it's only if it's directly touching, separated only by a line, not this space that inhabits these two. So adjacent, right next to, vertical, across from each other in the V's. Now vertical angles are congruent, they're equal, but notice adjacent angles are not always the same. There's exceptions. So like if I had, let's go back to our situation where we have a linear pair or a supplementary angle. Notice how, that's bad. Let's make this a little better here. It's not going to be perfect, but okay. So we have these two 90-degree angles. If I call them angle 1 and angle 2. Well, notice these two angles are adjacent. They're separated just by this line in between them. It's almost like two siblings who are living in two bedrooms separated by a very thin wall, and they're maybe yelling at each other through the wall. Those are adjacent siblings. These are adjacent angles. And in this case, they are congruent because they're both 90. And that is kind of a rare situation. Many times you'd have angles that are congruent. You'd have siblings sharing this wall, but they're not the same. They're not congruent. Okay. There you go. There's a little quick intro. Now let's dive into our assignment. And I'm going to log in because it's been a while. All right. Here we go. Also, make sure you have your Desmos calculator up if you haven't already. Let's look at this. All right, this is another little review. We have two angles here, 1 and 2. Notice that they're like the siblings with the line in between. So we know that they are adjacent. We also know that they combine to form this 90, which we learned recently means that they are like a complement is the right thing to do. They are complementary angles because they form a right angle, which means they're not supplementary. So it's definitely not that. They're not vertical because they're not across the V's like we just went over. Angle 2 is an acute angle. Well, if they add to 90 degrees, then they both have to be less than 90. And if they're less than 90, then they're acute. Straight angle is that straight line, so nope. Angle 1 also has to be acute. Complementary, yes. And not a linear pair. Okay, so you're going to look like 3 answers. They don't have adjacent right now. They just have acute, acute, and complementary. So again, this might be in a different order for you, but make sure you click those three. Oh, genius, thank you. And if you are wrong, just hit redo. Okay, let's see what it says here. Choose each of the graphs which angle 1 and angle 2 are acute vertical angles. Okay, so right off the bat, we want to find our x. But notice even though these x's are similar shapes, the difference is in where the 1 and 2 are. So angle 1 and angle 2 here are right next to each other, whereas angle 1 and 2 here are across from each other. Well, this is really clear to see. Remember what we wanted before. We wanted the v's that were across from each other. Not what's happening up here, where this is in a wide V, this is in a skinnier V. They're adjacent, but they're not across. So these angles right here are not vertical, but these are. So we have two pairs of vertical angles. We have the ones in yellow here that are small, acute vertical angles. And then we have this angles here and here, 3 and 4, that are obtuse vertical angles. And we know they're obtuse because they are larger than 90. And it's almost like it's making a yawning motion here, which means I'm probably going to yawn immediately. You can think of this as being one big mouth that's opening up. It's like, obtuse. That's how you could memorize that. Oh, you can't say oh without yawning really loud. Obtuse. Okay, there it is. There's the yawn. But we want the acute ones, so find the shape where 1 and 2 are right there. And match up your angles. It feels great to yawn. Only one answer for that one. Alright, there's only going to be one answer for the next one. If you need more time, pause it. Obtuse vertical angles are just the ones we went over now. So we want the ones like there, right here, that are large angles and across from each other in a V. Just like this. Find the graph that matches there. Pause until you do and then move on. Number 4 wants linear pair. So we're going to have 3 in a row that are like the situation I talked about with the straight line, but instead of being 90 and 90, they're going to just be random angles like this. So if you have angle 1 and 2 that are not across from each other in V's, they're adjacent because they're right next to each other with the wall in between, and they are on a straight line. Well, we know that 90 and 90, or if you're on a skateboard and you flip around, you do a 180, that forms 180 degrees. There are 3 names for this. We've got supplementary. Remember, twice as many P's, twice as many degrees. This is also called linear pair. People wrongly pronounce this linear pair, but it's still, that could be helpful because it helps you remember that it's a pair that forms a line. And then finally, there is straight angle, like a straight line. And it is interesting to me, again, I always apologize for my handwriting, that straight line, it's like between the two terms, you could see that. But 3 different terms for the same thing, and we're going to have them all reviewed right now. So let's go. Linear pair, we want to find 1 and 2 when they're right next to each other on a line. This is perfect because they're right above each other. There are 2 answers for these, and they're the ones that 1 and 2 are like this, where they're directly next to each other in any order. We're going to do this all 3 times. So commit this to memory. Right there where it says green. Find the ones that match. You're going to have 2 answers. Same thing for straight angle. So 1 and 2. And now they're not next to each other. I have to find 2 and 1. There they are. So we're going to literally do the same pictures 3 problems in a row to review the 3 different vocabulary terms that describe the situation of 1 and 2 being on the same line. So we had linear pair, we had straight angle, now we have supplementary, and once again, now they're next to each other again. We find the 2 that are right next to each other on the line. Not vertical, next to each other. Alright, when you get through 1 through 6, you've completed the vocabulary lesson for the assignment, and now we have a little SADME, a little algebra. So, vertical angles, which is what these are, because again, remember the flying hashtag Mighty Ducks V that are across from each other. These are congruent, meaning we can write this out. I always recommend writing these equations out next to each other. And then we need to go to our EMO acronym here. SADME. Here we go. Where we are subtracting and adding, dividing and multiplying, and then finally using exponents. Okay. So let's look at this. 47 equals 3x plus 1. We need to first subtract and add. I see in this problem that I am adding on the right, so I'm going to subtract. Always do the opposite and always do both sides. Minus 1, minus 1. That gives me 46 is equal to 3x. Oh, this is supposed to be 11. That's why this is looking weird. I'm going to subtract 11 from both sides, so that becomes 36. Ah, that looks much better. All right, so copy it down correctly. Now we have the situation where we have a number next to an x. That is the rabbits situation I talked so much about. They're multiplying. So divide. 36 divided by 3. That works out evenly. If you don't know, you can use your calculator on the right. 12. So in conclusion, or in summation, write your two sides next to each other with an equal sign. Do the opposite of adding and subtracting. Do the opposite of multiplying and dividing. And we have our answer. 12. All right. 7 down, 2 to go. 8 now is not a vertical situation. They're not congruent. We don't have any, notice we don't have any tick marks. There's not a little red tick mark here and here, or blue here and here that tell us they're the same. Instead, we just know that they are splitting this 90-degree angle, or they are complementary, because a complement is the right thing to do. So, let's do this. Figure out how many x's you have. I've got 2x and 3x. 2x and 3x make 5x. And then I'm going to combine my numbers that don't have x's. So a positive 20 and a positive 10 make a positive 30. This is technically a review problem from our supplementary and complementary angles number 2. And that equals 90. And then we do SADME. We subtract. And 5x is 60. Divide by 5. Oh my gosh, could it be? Yes, it is. I get 12 again. And then, because I don't want to cancel out right now this drawing, I'm just going to do number 9 right away, the same thing. So I've got this positive 3 and this positive 117 that are like terms. That forms positive 120. I do not have 2 x's, so it's just 6x. And that equals now, it's a straight line that these are supplementary, or they're a linear pair, or they're a straight angle, so they form 180 degrees. Okay, and then I do SADME. Subtract 120. I get 6x is 60. Divide by 6. Hey, I don't get 12 for the first time. It's 10. Okay, so set the top ones equal to 90, set the bottom ones equal to 180, combine like terms, use SADME, figure out x. You should not get a decimal. If you get a decimal, you know something's gone awry. Use your graphing calculator when you need to on the right. If you don't, then that's awesome too. We are both a mathlete extraordinaire, and we are tremendous. Okay. This has been vertical and adjacent angles. Hopefully you'll never forget that angles across each other in the shape of a V are vertical and congruent. And when they are next to each other, like two siblings separated by a very thin wall, they are adjacent. As always, I hope this video finds you well. Best wishes in all that you do. And until next time, this has been Class Away from Class. Dylan out.